Hello everybody, welcome to the third series webinar for kits that Paratech put out. This one's the Rapid Extrication Kit. Myself, Nigel Letherby, the Paratech Training Manager, Robert O'Donnell, the Regional Sales Manager, will be conducting this kit. Are you there, Robert?
Yes, Nigel, I'm here. Good morning. I'm at home here in South Carolina. South Carolina's starting to open back up, but still doing these webinars, touching as many people as we can. I looked at the list ahead of time of all the people that have attended this. I see a lot of familiar names, and some people are here last week as well. So thanks again for joining us. I'm looking forward to this. I guess, Nigel, you're at the factory?
Yes, I'm at the factory. The factory's still going strong. There's no cases here, so the office is down to minimal staff, but the production is going, the shipping is going. We're doing pretty good.
That is great. That's great. Thank you all so much for what you're doing there.
Okay, we'll start. Again, this is the third in a series of webinars based on kits founded in rescue. You can see the amount of kits we've done and what we are going to do. So it's going to be a pretty interesting month or so. Up and coming webinars. We got the hydrofusions next week, highway vehicle stabilization kit the week after, interstate motorway the week after that, heavy vehicle extrication kit. That one's going to be a pretty good one. We're going to go in depth with that one more. And the strut driver is going to be the last one in this series. We are going to carry on with the webinars as the year goes on. So we'll see what happens, and hopefully Illinois will start opening up a little bit in the next month. We can get out there and do some demos. Again, this is a PowerPoint presentation. This is for informational purposes only. It's not a substitute for hands-on training taught by a qualified instructor. Regular hands-on training is necessary to become proficient. Improper use of any of the equipment you see may cause serious injury or death. Think safe, act safe, be safe. Always lift an inch and support an inch. The history of Paratech. We continually strive to manufacture the very best of rescue equipment. Our engineering staff are constantly trying to come up with new ideas and to make things more efficient, a lot easier for you to use. So they are on there 24/7 trying to come up with ideas for that. If you take a look on the left-hand side, you see the Paratech timeline. We started in 1962, and you can see what developed through the years and what we did through the years up to 2020. Again, this is the Rapid Extrication Kit. We've covered both kits that's in this one kit previously. If you take a look, we've got the multi-force replacement kit and basically the standard vehicle stabilization kit that makes up this Rapid Extrication Kit. So we can lift as well as stabilize on this kit. Capacity of the struts. In the kit, we've got two of the 25 to 36 inch struts you see there. I just put this table together to give you a little bit more of an understanding of what these struts will do. Again, it gives you two complete legs for stabilization from 32 inches to 75. You can put together a tension buttress or same size stabilization. It doesn't make a difference. But remember, this is not only for stabilizing vehicles. We can go in with this and stabilize houses. If you've got a car in a building, something like that, where the house is more dangerous than the car, you can take your stabilization kit and actually stabilize that house. If you take a look at the leg capacity on the struts, with a 4-to-1 safety factor at 32 inches, you get the maximum of 20,000 pounds with a 4-to-1 safety. The 20,000 pound is with a 4-to-1. I'll try to explain it. Multiply the 20 by the 4, gives you 80,000 pound. So up to 4 feet, that strut is an 80,000 pound 1-to-1. Again, divided by 4 gives you a 20,000 pound workload. At 48 inches, using struts and extensions, we still get a 20,000 pound capacity on that strut. At 75 inches on that leg, which is the maximum that leg will do with a rule of thumb of extensions, we get around about 14,125 pounds with a 4-to-1. If you take a look at the table below, we put a table in there with a 2-to-1 safety factor, which is actually on the new labels on the Acme rescue struts now. At a 2-to-1, 32 inches, we got a 40,000 pound. 48 inches, we still got the 40,000 pound. At 75 inches of the 2-to-1, it bumps up to 28,250 pound. So they're pretty strong, and it's a pretty universal tool to go in. This kit actually gives you 2 legs, but as we go on throughout the month, you'll see kits that will develop a lot more legs and give you a lot more capacity in this. The multi-force replacement kit. Again, it's one bag with 2 stages, made of neoprene with a continuous weave of aramid fabric, Kevlar. It's got internal relief valves for safety, single bag that telescopes up in stages with a lift, no interlocking plates or collars. If you take a look at the 2 pictures, the kit is on the left-hand side, comprises of the bag, the star foot, the remote placement wheels and handle, along with 2 hoses, controller, regulator, and of course your inline shutoff valve, in case you need to disconnect the controls. The one on the right gives you the 3 stages that the bags go up in. The first one is the bag completely flat. Takes about 3.5 inches to put that bag into place. Starts to lift, the bottom section inflates first, makes contact, starts to lift. Around about 5 to 10 psi, the top section comes in, starts to lift, takes it all the way up to 26 inches. This bag is a 31-ton bag, and it will lift 26 inches. It's a pretty versatile, and it's a pretty stable bag. Do you need to add anything on that, Robert?
No, you're right, Nigel. It's an amazing bag. It does lift those full 26 inches all the way up, like you said, instead of at about 5 tons. And the engineering team has always shared with us that that's a very conservative figure at 5 tons being all the way up. So it's an impressive bag. The pictures that we'll see later here are a lot of the pictures we saw last week. I saw some duplicate of the names, and thanks again for joining again. But you'll see just how effective it is. I have never been anywhere that someone has not been impressed with the ability and the capability of this bag.
Cool, thank you, Robert. Okay, going back to the strut multipliers. For those who wasn't here in the last couple of weeks, the strut multipliers, you'll see the table on the right hand side, along with the information on the left. At 45 to 60 degrees, we use the stabilization for light vehicles. 45 to 60 will stop both vertical and horizontal movement of that load. Larger vehicles, we prefer to go into the 60 to 75 degree mark. That way, the load that it's supporting, most of the load is going to ground and not trying to push that base out on that stabilization. It's all about compression on the base plates and anchors when we deal with heavier loads. Your ratchet strap is a 3,300 pound strap. We also deal with grade 80 and grade 100 chain. The grade 80 chain is a 7,100 pound chain in a straight pull. It gives you 14,002 in a basket. If you choke the 7,100 pound chain, you lose about 80% of that capacity. You lose about 20% of that capacity. You'll gain 80% of the chain in a choke. The same with the grade 100, except it goes up to 8,800 pound in a straight pull. The vehicle weights. I added this little information sheet in here so you can see the different vehicle weights and what we're dealing with when we're out in the real world. These are actual weights that tow operators use when they decide what equipment they need for the job at hand. If you take a look at that little Corvette that's down there, if you can see it, it's relatively small, it's light, maybe 1,500 pound per axle, gives you a 3,000 pound load, going up to some SUVs, some dump trucks, going up all the way to your class 8 semi, 80,000 pound semi. But it gives you a look at the axle weights. If you take a look at the semi up on top, the front axle of that semi is around about 12,000 pounds. Every axle after that is around about 17,000 pounds. Gives you the 80,000 pound mark. A lot of people out there, a lot of instructors tend to round up the axles and put the axles to 20,000 pounds. That way then you know that you're well within capacity of the equipment you were using to stabilize or even lift that vehicle. School buses are there. If you look at a school buses are around about a 30,000 pound bus, the long class 8 ones. But you'll take a look. You've got a 12,000 pound front end of the school bus with the engine to around about maybe an 18,000 pound back end, a 20,000 pound back end. Your deployment on this, you're still going to do your 360. You're going to pick a place where your stabilization is going to go. Remember, don't put your stabilization or lifting in a place where you need to extricate that patient out of that car. Decide on where the patient is coming out for your egress and your exit. If you put your stabilization in the place of, for example, where the stabilization is going there, it's on the fenders. Not really a great place to put stabilization on the fenders, because as you guys know, if weight comes onto that stabilization, it's going to buckle the fender a little bit. But the fender will eventually stop buckling and make contact with some solid material under there to stop the car from coming down. What they need to do is they need to open the doors on this. That's why they put the struts on the fenders, so they can open the door. They do the lift, you chase the load with the struts. Then what you'll do, you put a little bit of load back on the struts of the airbag. That way, the struts are actually doing what they're supposed to do, which is holding that car from going laterally and vertical when you do your extrication. Connect the air source and controls to the multi-force before you put the multi-force under that vehicle, especially the hose on the multi-force. The reason is, I've seen it a lot of times where they get excited, they push the multi-force under the vehicle, then they forget to put the hose on. They're going to bring the multi-force back up to connect the hose and do the procedure all over again. Always remember, lift an inch, support an inch. It's hard with the multi-force because our multi-force goes up pretty quick. So you've got to be on your game with the two rescuers, one on each side of the car. You've got to be on your game to support that load as it goes up. Try to have the ratchet belt already attached and not tight, but you may need to slide the bases in slightly because of the length of the struts and the adjustment in the struts, and take the slack out of that ratchet belt before you ratchet the bases home and stabilize that car. Tension buttress system. Take a look at the picture on your right hand side. This is a dump truck, 12,000 pound front end. We put a tension buttress system on there. This one had a plow on the front, so it had a very strong front end. So we were able to put the stabilization in place outside the footprint of that vehicle. But if you take a look, your multi-force is actually on a crib-based, a small crib column going up to your axle. Did we need it on this? Not really. We could have just slid the multi-force under, made contact with that axle and did the lift. But what you need to take a look at with the multi-force, in a situation like this, if I'm on a crib stack, two rescuers need to crawl under that vehicle to place that multi-force. The reason is, one guy laying on his side with one arm trapped under his body by his shoulder is not going to lift that multi-force on top of that crib column without the crib column moving out of place. So you get two guys going under, lift it into place, make sure it's central, and away to go. Now, if we didn't have the crib column there, we could just slide that multi-force under there with the remote placement handle. The thing is, what you're going to look at with semis and dump trucks, that axle's in around about 5 feet from the edge of that bumper. So it's not an easy placement. You're going to place it under. The multi-force does come with an optional flashlight kit where you can put the flashlight on the handles. The flashlights already point upwards. So as it goes under, the lights hit the axle. Once the lights hit the axle and goes around the axle slightly, you're central. But what you can do on a dump truck or semi is that the hood opens forward. If you open up that hood, then it exposes that axle where the multi-force is going to go. It also exposes all the framework and all the axle behind the wheels. So you can actually see through that gap where the multi-force is going to go and how it's going to go onto that axle if you don't have the flashlights, or if it's like this daylight where you won't see the flashlights. The picture on the left is the same size stabilization and lift. If you take a look, we've stabilized that. Again, I think that's a dump truck. We stabilized the dump truck using the stabilization kit. It went back to the back side of the truck with its ratchet straps to hold it in place. The struts are on a good angle, maybe around about 70, 75 degrees. Then we put the crib columns in place, one in the front, one in the back, put your multi-force on top. Then we did the lift with the dump truck and followed up as we went. If you take a look at that one strut, you can just about make out the blue hose that's on that strut. We've actually got a hose going to the other strut as well. And on that strut, we've got a VSK controller, which you will see later down the line. The VSK controller gives you 25 PSI into that strut when it's charged. That's all that does. That it allows the strut to chase the load as it's lifted, and it allows the rescuer then to just go in arm's length and spin that collar down as the load lifts. So the threaded shaft on that strut actually chases that load up. Keeps the rescuer out of harm's way, and everything goes up nice and smooth. You lock out the struts when you're done. Again, take a slight pressure off that bag so it rests on the strut so that the load doesn't bounce. And you're good to go. Stop in the crush. You're going to see this a lot as we go on with the different kits when we deal with the heavier vehicles. Stop in the crush utilizes one of the struts in the kit. As you see, this one here, I've used the actual kit bases themselves. I used the hinge base, the 12-inch hinge base at the bottom, and I used the multi-head on top. If I got an underride going under the semi from one side, I may only want to stabilize one side of this truck. So when you do your 360 on this vehicle, first thing you do, you're going to put a stop the crush strut in. Basically, stop the crush normally goes vertical. It works better if you've got a rigid base or a 90-degree base on the bottom, because then the strut doesn't move around like it does with a hinged. But that one goes in place. You tighten it up, it's down and dirty, tighten it up to the vehicle. Then you can come in and place your stabilization struts. That's all that does, is it stops that semi-trailer from coming down any further onto that car. As you know, with the suspension on the semi-trailer, it's actually air ride suspension. So if there is a problem that the airlines are compromised, then that suspension is going to basically raise and that box is going to come down. So it's always settling into that car, onto the driver of that car. So that stop the crush strut goes in virtually alongside the car, out of the way, to stop that from the load from coming down any further onto the driver's lap. Once that's in, you can concentrate more on your stabilization. Stabilization goes in, then you can place your bags to do a lift, or however you want to lift the semi. Excuse me while I take a drink of water. Anything to add on that, Robert?
No, Nigel, it's perfect. You're right, it's stopping the crush. And you were saying that you use the bases that are in that kit. You know, those bases, because we're talking about the Paratech Rapid Extrication Kit. Those are the tips that come with it, but you're talking about a 90-degree base down at the bottom, a rigid base, or even a swivel base, so a 6-inch rigid swivel base at the top. So we can capture more of those members, maybe with a piece of 4x4 across. So many options, but this kit affords us to be able to build on it and go further. So for a rescue pumper, if you're getting a new rescue pumper, this is great. It doesn't have all the compartmentalization that you may need with all the other firefighting equipment that you have to put on there, but this gives you the lifting capacity and the stabilization capacity that you need in this one kit. And then you can build on it as you go. You can get the rigid bases, or other pieces as you go forward and build out your rescue system. I always like to say it's like Legos. I mean, they keep it expands, 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 expands. You don't just build one item with it. And that is the great thing again about this kit, is that you can build upon it and go further. So I'm going back to your pictures again. These pictures, these slides are showing the pieces that are in the kit. But where we can go with this kit is a great footprint to really expand your rescue capabilities.
Thank you, Robert. And remember, when you're dealing with a van trailer, which is the ones that are bundled down the road every day, your UPS, your FedEx, and whatever else goes down there, when you place your stabilization in place on that van trailer, always remember to capture the actual cross members that's in that trailer. If you take a look at those rivets or bolts down the side of that trailer, I've got the stop the crush strut actually on one cross member, then I got my stabilization strut on the other cross member. Just remember to capture those, because if you don't, and you do the lift on those struts, actually stabilize that van trailer in between the rivets or in between the cross members, that's just a thin piece of aluminum. And if weight does come onto that strut, it's going to tend to tear that aluminum a little bit. Then it goes up, and then the only thing it's going to make contact with is the plywood floor or the wood floor that's in there to stabilize that vehicle. Again, we don't know what's in that vehicle. So it could be heavy, it could be light. We don't know. Scenario underwrite. If you take a look, accident where the sedan ends up under the semi-trailer, crushing the post, crushing the dash down. This is the scenario that you just seen. Again, scenario, stop the crush. We're going to put the stabilization in place. We're going to ratchet strap or pick it between the struts. Remember, we don't know how heavy this vehicle is. If this is a steel flatbed or something like that, then I doubt I'm going to use a ratchet strap. I'm going to use chain binder, or a boomer as it's known. That way we can tighten the chain up between the bases. It gives us more capacity than the actual ratchet strap. Then we're gonna place our basically airbags or your multi-force on the top of the two wheels. For this to work, these wheels have got to be inflated. If you take a closer look at that bottom picture, you'll see under that multi-force, I placed a 4x4 piece of wood in between the two tires. That's all that's doing, is giving me some surface area for that multi-force to make contact, or an airbag to make contact, so it doesn't dip into the two tires, into the two wheels. It gives more support of those two tires. Then I took a piece of 3/4 plywood on top, so I can span a couple of those cross members of that trailer to do the lift. You can only see the one multi-force on top of the wheel. The multi-force, because it gives you a lot of lift, a lot of height, and a lot of capacity. It will do that lift, and it will lift it up to a lot of height. On a air suspension trailer, you'll gain around about anywhere from 8 to 15 inches on that. And for that underride, it'll be enough where I can lift that underride, that trailer box up off that car, and the trailer will still be stable, because the wheel and the axle of that trailer is still in contact with that ground, so it's not floating. So that trailer becomes very, very stable. Also remember, as you do a lift using this multi-force with that box, you're going to lift an inch, support an inch with your stabilization, but also have a rescuer down to the front end of that trailer to work that landing gear. Try to maintain contact with the landing gear on the ground. If it's not attached to a truck, which sometimes it's not, the kingpin could have snapped, truck could have come loose, driver freaked out, and maybe moved the semi out of the way, who knows. But what that landing gear does, it gives stabilization to the trailer also. If you live in an area where there's wind, that's all that trailer is, it's a big sail. And that landing gear gives it a lot of sway support from side to side, especially in the wind. So it works real well. Again, the scenario is the same scenario. On this, we've shown you a couple of different ways where we can lift the box. On the top picture, you see we built a crib column. It's a substantial crib column for the multi-force to go on to lift the box. It's lifting the box up, but remember, the box is only going to go up so far until that suspension comes into play and starts lifting the wheel off the ground. If it lifts the wheel off the ground, then you own that vehicle, because that vehicle now is suspended. If you're going to do that, try to chain up that suspension to the frame. On a van trailer, it's hard because there's literally no frame on the van trailer. That van trailer at the back end has got a small frame with a series of holes where that bogie or the bogies, the two axles, will move up and down that trailer for weight disbursement. Depending on how heavy the trailer is. This could be a good visual for you guys out in the field to see if a trailer is heavy or not. If the wheels are all the way forward of that track, which is basically a third of the way up that trailer, then the trailer is pretty light. The wheels are taking a lot of weight of that trailer. The weight comes off your tractor a little bit with your bogies all the way up to the front. But if your bogies are all the way back to the DOT bars, then what the driver's done with that, because that trailer, the weight of that trailer is pretty heavy, he's putting more of that weight of that trailer onto the semi-tractor itself. So that's something you can do as a visual, whereas if the bogies are all the way back, you know the trailer's heavy or they intend to carry something heavy. If the wheels are up to the front, the trailer's pretty light, like a UPS trailer that's full of parcels and light boxes, but high volume. But on that, you can see we've got two ratchet straps going to that base, from base to base. Two ratchet straps give us 6,600 pounds on that stabilization. What that does for us, it beefs up both ratchet straps for compression on those bases. But what you're going to be careful with, I said but, what you're going to be careful with these two ratchet straps is that you try to adjust them equally with the same tension on them. Otherwise, you can overstress one until the other one comes into play. Don't crank one up all the way as tight as it can go and just leave the other one loose. That doesn't work. You need to utilize both capacities of both ratchet straps in that situation. The bottom one is the lift you saw earlier in the slide previous, with the multi-force on top of the wheels. As you can see, that track with a series of holes there with the bogie slide, and you can see all the ribs that's on the bottom of that van trailer. The other thing this will show you, if you take a close look, you'll see that piece of 4x4 in between the two tires. Remember, this is only going to work if the tires are inflated. Don't put the bag on the dualies if one of the tires are flat. Anything to add, Robert?
No, you're tracking on everything there. I did want to talk about the suspension, though. You mentioned about capturing the suspension, and it's a great discipline to know. It's really something to train on, because there are so many ways to get a chain in there and bind it up and get that ratchet chain binder in there. But on the scenario that we're actually showing here, which was a side underride, because the wheels aren't involved. And again, I'm just talking about it so the viewers out there, when they see it, we don't necessarily have to capture the suspension. The suspension of that tractor trailer is not involved in this scenario. It's not, the car's not underneath it, the victim's not underneath the suspension, so we can leave that suspension right there touching the ground the whole time, or leave the tires touching the ground and keep that suspension down as it goes. So sometimes sometimes it's our benefit to not capture it and leave it in place and get a little more contact. Maybe we block it out, but not so much that we have to capture the suspension and pull it up off the ground, unless we were trying to get that clearance on it. So just wanted to point that out there.
Thank you, Robert. Okay, another scenario we've got. This one's involving the tractor. Excuse me. You're still going to follow the procedures with stop the crush and everything with the tractor before your stabilization goes in. This one is placing the multi-force under the differential of the tractor to do the lift. What you've got to check when you do this, your stabilization's in place. As you see, we've got a VSK controller attached to this because of the close placement of that wheel. And remember, on this side of the strut is you most probably have air tanks or fuel tanks, depending on what tractor it is. But we placed our multi-force under the differential of that truck. What you've got to watch with trucks, especially dump trucks and some semis and some school buses now, is that that differential is off center. Take a quick look under to see where the differential is. Don't take it for granted that differential is right in the center of that axle and you can do a lift. So what an offset differential does for you, it will tilt the truck. Remember that differential is a ball. So you're trying to lift on a ball. There's a little bit of a flat surface under there where the drain nut is, but not a lot. So with an off-center differential, as that truck lifts, it tilts and it's going to want to slide towards the right of this picture as you see. What that does, it puts that bag in a little bit of a compromising situation because now that bag is staying where it sits, but the top end is moving slightly with the differential, and it may slide on the differential, which is going to push that truck over, and you're going to lose your lift. You may even lose your stabilization because it'll want to angle the stabilization on the right-hand side of the truck more vertical, and the stabilization you see more horizontal. So you've got to be careful with that. If you got a lift on that differential, try to pad out the axle on the long side of the differential. That way, that pad out helps you a little bit. Put some 4x4s in there. Put them long ways. What I mean by long ways, put them across the differential, so it makes a cross with the differential on top of the bag, and it may end up helping you out doing the lift on that differential. But be careful lifting on a differential. The other thing you can do to help you out is tiebacks. If you tie back the truck one way and tie back the truck the other way, the truck's got nowhere to go laterally, so you'll be able to do your lift. But remember, with your tiebacks, don't tighten them up so tight, whereas as you're doing a lift, now your tiebacks are fighting with each other on that truck because the truck's going up and you're tightening up the tiebacks. Again, you can use grip hoists or any come along to do that. You can even use a ratchet strap to do that. Doesn't take much to hold that vehicle in place while you do the lift. The good thing with the grip hoist is the grip hoist you can take in and you can also release. So it helps you out a lot. It's a lot easier. Anything to add to that, Robert, on that one scenario?
No, sir. I just wanted to, we'll see the slide again in a little while. I'll go over the hoses there.
Okay, cool. Robert, do you want to talk about the multi-force?
Sure. The multi-force here, you'll see it under the rear of the sedan. Again, it's as Nigel's been talking about, it's a very stable bag. You'll see that this is a remote placement. You can barely see in the left-hand column, left-hand corner of that picture where the handle's connected to it. They left the handle, they got the yellow hose hooked to it, and they've lifted the car. So this purchase point right here is under the rear of the sedan. You see the muffler there, and you can also see the tire well. Always make sure that your placement is secure. We want to make sure that our purchase point is stable, that we're lifting off of. And again, like Nigel said about that differential, those tire wells actually kind of have the same type of consideration. Some of them are rounded, some of them aren't as strong. It's not actually a frame of the system or a frame of the vehicle. It's just a part that where the well comes down and the spare tire holds. Also, on some trucks, like an F350, maybe the wheel is actually stored behind the back and not in a well itself, but you actually have the tire there. Make sure that the tire is stable and that you're lifting off. And you do want to be careful that you don't lift right off of that tire. If you can, it'd be better to go to the framework of the vehicle itself and get a lift. We don't know how secure that tire is to that vehicle, especially with the amount of rust that we have on the vehicles traveling in the north from the salt and all that due to the weather and the conditions on the roadway. So we don't know how much things may be rusted. The applications of the multi-force here, these are still using the multi-force with the rapid extrication kit. On the left there, you see the van has been lifted. What happened here was an underride for this scenario that was set up in this training class. And on the underride, they actually hit a victim. So you can see that there's a victim on top of the hood and the van was on top of them. So what they did was they cribbed up that remote placement multi-force, ran the lines to it, put Paratech struts on either side to capture the load and stabilize that van up, and they're going to lift it off of that person. what they don't have here in real world, in junkyards, a lot of time we don't have the tires. So this is at a scrap yard or a training center where they got a vehicle brought to them. It doesn't have the tires on it. On that front blue vehicle there, or the rear blue vehicle, you'd want to make sure if it had the tires there that you capture the suspension. So by capturing the suspension, it's going to hold that blue car down as you lift the van off of it, and then you get that victim out. So even if you don't have the tire there, again, because I know we run into that a lot in the scenarios or the training exercises we get, we're at the mercy of the junkyard to get us the vehicles. Still practice tying down your suspension. Maybe the suspension, maybe there's a tire on one side and there's not on the other. And of course, that can happen in a real wreck. So practice putting that ratchet strap against there, across that blue hood, and capture that suspension down so we lift the van off with the multi-force and support it with those two struts on either side, that we still get as much gap as we can to get that victim out. The middle picture there is another rapid extrication kit. It's being used to lift the loader, the rear end of the loader. The loader is a very heavy piece there. It's probably got a Caterpillar tractor back in the back of that. And they've blocked it out. They put it up on cribbing. They blocked up, and the reason they blocked it there is to get more of a purchase point to transfer more load on top of the multi-force to the loader itself. And then they're using the multi-force to lift within the two struts to stabilize. This slide on the right, again, is showing that differential. Nigel covered that differential. It is really important. A lot of our training exercises, we're seeing the school buses, they're readily available, and someone always wants to lift off the differential. I like doing it in a training exercise so people will see that it's not really a good option. They're round, they do move, and they move so much that we just can't control that load. So know that those airlines that are running to those struts are so that the struts will be chased with air. So those airlines themselves are not with the struts. They're not being used to lift the load. They, again, just chasing it with the VSK controller, as Nigel had mentioned earlier. This one right here, this slide right here, this slide is really gets a lot of comments. I hope you guys are talking about over there in the chat where the other RSMs are there to answer questions. In this particular one, we feel that the engine's got to be in the back there. You can see we're past this, or we're right at the center of gravity there, going from the rear to the front of the vehicle. But again, rapid extrication kit again, we've got the multi-force bag that's been cribbed up underneath the load. It's got plenty of capacity to capture the load. There's a ratchet strap that is going, I don't see it like this often, but I see a ratchet strap going all the way over the top of the bus to hold the suspension of the vehicle up. And then they've got the two struts in place for the stabilization. So a great way to do it. It shows all the pieces of the rapid extrication. Please, if we look at the hoses again, we notice that the hoses are attached to the struts. And when they're attached to the struts, that's just to chase the load again, not to lift with. They do have a VSK control in there, as we've been talking about. Our slide here says, what could we have done to make this lift safer? So we know that we've stopped this movement vertically. We've lifted the bus vertically. We've stopped it from, because our struts are in compression, this bus is definitely not going to come down. The struts are up underneath it, and the bag's underneath it as well. But we don't have a lot of, we've got some, but we don't have a whole lot of lateral stabilization. So we could laterally stabilize this with either a grip hoist or ratchet straps to stop that movement to the left or to the right and keep that wiggle out of that lift as it goes high. Again, this is a very, very high lift. I imagine that it was an override at some point. They've already, this slide here is after they removed the vehicle from the front of it. Maybe they grip hoisted it out, or they used a winch to pull it out. So a lot of lift there. Of course, with an auto pedestrian or bus on top of the car, a bus on top of a victim, we wouldn't have to get that much lift out of it. So there's probably an override situation where they already pulled out the vehicle. The rocker rail insertion. This is really one of my favorite uses for the multi-force. You all know that in a auto pedestrian, maybe a motorcyclist, first a car or a moped, that the car never goes right on top of it. It doesn't sit square on top of the victim. It actually rolls over the victim. And as the victim is rolled underneath there at the front, there's not a purchase point to put our bags because there's the victim and maybe the moped or the bicycle up underneath there. Taking the multi-force, as you see in these three pictures here, and going to the rocker rail is a great point It's a good purchase. The rocker rails are solid. Sometimes, again, we definitely need to be concerned about the rust that you all see in the Northeast with the amount of salt that you see on your roads. But getting that purchase point there, if we didn't take the rocker rail, we could go in a little bit further. This is probably a unibody construction, but if this was a F-350 or some type of vehicle that had a frame rail, we could go and slide it a little bit further past the rocker rail and get to that frame. But what it does is when it lifts there, it still maintains 3 points of contact. We have the two wheels that are on the driver's side that remain in contact, and we have the multi-force bag that as it inflates, so you'll see the first stage on the left is up, and then in the middle picture there, the second stage starting to lift, and then the third picture on the right, it's all the way, it's fully extended. It shows two things here. One, it shows you the amount of clearance that you have. It also shows you the stability of the bag. You'll see that the bag is kept in line. The bag itself is kept in line with the load. So as the load moved a little away from what was the center of the bag maintained that contact and is transferring that load through that first stage of the bag down through it's coming down from the second stage of the bag, transferring down to the first stage of the bag, which is all one bag. There's no rings there. There's no interlocking mechanism. It's all one bag, one hose, one button, and it's transferred down to that wide star foot. So that base is maintaining that stabilization and keeping that footprint so that we can transfer that load down. But why I like it so much is the amount of access now that we have to the victim to be able to get up underneath there. Perhaps during the rollover or the run over, the driving over of that victim, maybe if they had that motorcycle or bicycle, the motorcycle or bicycle ended up on top of the victim as well as it rolled over. Now we've got plenty of room that we could get the motorcycle or the bicycle off and get that person up and have plenty of room to work. Another handy tip is if we're in this incident right here and we do have a bicycle or a motorcycle that's underneath the vehicle but on top of the victim, is we can connect those loads together. So because we want to get the vehicle off the person and we want to get the motorcycle or that bicycle, we could ratchet strap or chain with a ratchet chain binder that motorcycle or bicycle up to the car real quick, make those two pieces one, and then use our multi-force on the side to lift them simultaneously and then be able to get the victim out from underneath each piece. So just another option there, but I really like that rocker rail. You'll also notice that I put in there lift an inch, crib an inch, or lift an inch, support an inch. It's important to us just to talk about that and stress that here we made these slides intentionally. We were not focusing on stabilization here. We did not have the struts out. We want to be able to focus on the bag itself. We do want to make sure that we put our struts in there. Of course, the Rapid Extrication Kit does have those two struts that would have been perfect here to be able to put into the wheel wells.
Can I just add something, Robert?
Oh, please.
If you take a look at that picture all the way to the right of that multi-force lift in that car, if you take a look at it, if you've all used conventional airbags where you stack one airbag on top of the other, the bottom airbag will remain parallel to the ground it's on, and the top airbag will remain parallel to the load it's lifting. Well, the multi-force does the same thing. If you take a look, the bottom section is parallel, virtually parallel to the ground it's on, and the top section is going to go parallel to the load. So you will see that little bit of a bend. And that's a good thing, because that way you don't lose surface area on the lift side or the underside of that bag. Thank you, Robert. Horizontal shift with the multi-force is placed alongside a jersey barrier or some sort of concrete, another vehicle that may be heavier than the vehicle you're trying to move. Placement is crucial on this, so as one, you don't turn the wheels, because this is a steering axle of a dump truck. One, we don't want to turn the wheel. And two, you got to make sure that your anchor point, which is either the jersey barrier or another vehicle, is solid and in contact with the ground and it does not move. So what we've done, the first picture, the bag placement is in. It's up against basically the center of the axle of that wheel. Second picture, we've moved the vehicle away. If you take a look at the 4x4 cribbing we've got down at the bottom, we just put that down so as we could offset that star base so the two legs make contact with the cribbing, so it holds the bag there, so we don't have to keep holding it until it makes contact. Then the bag will come loose once the vehicle is away far enough, so the bag's all the way extended and then both vehicles are separated. So this is a great, not so much a lift, but it's a great way to show this multi-force in a different application of pushing away a vehicle, separating vehicles, separating loads. Structural claps, we can use it to separate walls or different things on a structural collapse. It works real well. But remember this. Yes, sir.
No, I just wanted to make sure I lost my connection there for a little while. I came back. I did want to comment on this one here that I know this is in the back of the factory here, but we always get a lot of comments on this one. This is that same dump truck, just for our viewers, that they used earlier with the multi-force under the front. So that's a 12,000-pound axle there, and that dump truck again has a full engine in it. And it was also very beefy because, as Nigel was pointing out earlier, it had a plow on it. So that is the full weight. So it shifted that front axle, all that weight, and it just pivoted on those rear wheels at the same time. So I just want to make sure that everybody knows that when people saw the video that this was made from, I had a lot of questions about whether it was actually if there was an engine in there, if that multi-force was strong enough to push that out. And as you can attest to, Nigel, it's more than strong enough to do that.
Yes, and with this, as you see, this one was on gravel. You'll get different friction on different surfaces, asphalt, concrete, things like that. If you are on asphalt or concrete, a good way to do this so it transitions to that slide nice and smooth is hit or hammer some wedges on the inside of that tire, under the tire, on both tires. That way the rubber then will ride up onto the wood and the wood will slide a lot easier than it does with the rubber on concrete or asphalt. Okay.
Other applications here of the multi-force, we see over on the left picture here is the multi-force being used in a rail yard. This is actually up in Canada, and they've got the two flats there, and they've used it's the remote placement, so I can see the handle sticking out right above the blue hose there. They've left the handle in place, but they've just used it horizontal to get those two yard flats and push them away from each other. Actually in the same kind of configuration that Nigel did with the dump truck up against the Jersey barrier. In the middle picture here, that's the subway at New York City at the FDNY at the Rock, their training center. They have a full-blown subway mock-up that they do all their training in, and we took the multi-force there and put it in a horizontal position using the handle at the top there that you see to slide it into place. We then pressurized the multi-force and removed the victim. There's a video on Facebook out there of this actually happened in the full video, and it's very smooth, it's very fast. Again, we're pushing away from the platform, so we put the base of the multi-force against the platform itself, and then we're using the bag to push the subway car out and increase that purchase point. What you can't see there are the step cribbing and the step chocks that are on the other side that are capturing that progress as we push the bag out. And all the way to the right is a picture that was sent to us from Connecticut. This is a real rescue, and this woman was trapped between the house and the vehicle. There was snow on the ground, and the fire department did a great job, not only in transferring that load and dispersing it against that front wheel by using that 3/4 plywood up at the top, but you can also see where they took it and they cribbed it out from the house. You know, they cribbed it out for distance, and they also cribbed it out to spread that load. So they're spreading that load. There's no telling what's in that wall. Maybe it's 2x4s, maybe it's 4x4s, maybe underneath that bottom plate of that construction is some concrete. So they're actually dispersing that whole load. They've got plywood up against the house and then cribbing to disperse that load onto that multi-force base and shift the car again with the base from the house up against the house, pushing that car away from the victim. It's always nice to see. We do get several times a month, we get things in the customer service where people are sharing using our equipment in real live rescues, and this is another great example of that. The preview of what's to come. We've got a lot of other webinars that are on the board here that like Nigel showed us earlier. You can see here we've got some gold struts in here. We're going to talk about some rapid extrication kits. I know the next one coming up is the hydrofusion. Mike Uliberry from Utah, our guy in the Western Territory, is out there. He's making a presentation on the webinar for a webinar on the hydrofusion. So you'll see a hydrofusion on that garbage truck here. We have a lot more things that are coming in the future to talk about. These webinars are new to us, and we're getting a little bit of hang with it. Of course, we're at the mercy of technology here being live. I told you I lost that feed there for a second, had to click back on and get ramped back up, but Nigel kept it going, and we're happy with the way things are going, and we're happy with the attendance, and we're getting some positive comments from this. So again, we're just finding other ways to be able to reach out to people while we're here and going through these times. As a follow-up, the regional managers will send an email to you, and thank you, of course, for attending, but give you links to the video and also give you a link so that you can sign up for the next one. The next webinar is going to be very good. Mike's put a lot of effort into it. Our hydrofusions are a very popular item. You know, in any big rig rescue, I don't really know how we've been doing it for all those years without it. They lift a tremendous amount of weight, 10 tons each one, and without getting into Mike's presentation, I'm just trying to get you thinking and get you wound up to try to pre-register and come in and watch this hydrofusion one that's coming up. To leave on the next slide here is we just want to leave with planes, trains, cars, trucks, military, industrial. Again, using the multi-force that's in the rapid extrication kit and all these different pictures here to get that purchase point, to get that lift, to provide the lifting mechanism, and then the 2 struts that are in that kit to be able to support that load and keep it stabilized as we lift it and capture our progress off of the victim or off of the vehicle that we need to do. So Nigel, I want to thank you for letting me attend this with you today, and I hope everything at the factory continues to go well. I do appreciate that everybody's out there working hard and continuing to make the products for us. So I do talk to the ladies in customer service quite often, but please thank everybody else in assembly and shipping and all for working hard. Thanks for all the knowledge you've shared with me over the years, and we're still learning. I know we learn every time we do something. Can't wait to get back out. I do have some things scheduled later on in this month, both in North Carolina and South Carolina. Already a couple of weekends scheduled, so that's good news. So I hope you guys will be opening up soon up there in Illinois, and then everybody out there that's watching from all over the country and abroad. Be safe. Good luck to your families. And if you need anything from us, you can go to www.paratech.com. There's plenty of information on our website and our libraries about all the different items that we manufacture. So Nigel, thanks again.
Thank you, Robert. Thanks for your contribution. That was great. Thanks, everybody. I hope you enjoyed it. As Robert was saying, the question and answers will be open for a little while with this picture up. So all our guys are on the site answering questions.